This video is starting in a place where you don't think it's going to end. I'm here to tell you right now. How you doing today, Zane?
I'm great, man. How are you?
So what are we doing later on this week?
We got the BBI Bakerman break.
What year is it?
2021. Is that what it is?
That's the current year, but let me switch sides of the t-shirt so you can actually speak into the microphone so the normal mortals can hear you.
2021.
Mr. Whispering Jesus. Okay. So, what we have here is a new part. Well, it's not new. How long do you think this part's been out? I know that
I don't know. I've had them for like 6 months or so.
Yeah.
I like them.
I started hearing about this a few months ago. I don't know. Everything is running together at this point. But this is a, quote, new chipper design from HK International Electronics / UT Source / HK Limited Electrical / HG International.
Is that what it is?
Well, the wafer is designed supposedly by HG. All the surrounding components, the tabs, the pill foot, the case, and all that stuff comes from a subsidiary of some kind or another from HK Electronics International in China.
You must have gone down a rabbit hole.
I did. I dove all the way to the very bottom and even smoked a little bit of the green stuff with Alice at the bottom. Went, dude, it's cool. And I asked her to show me her boobies. She slapped me, and then I got to see them.
Wow.
She'd been down there for a while.
Oh, no.
The very, very bottom of the rabbit hole.
Sagging.
Oh, that was a rabbit. Come to find out, back then, in the animated movie, that was actually a chick.
Oh, boy.
They were wobbling to and fro. You could hear them. They're slap like biker boobies. It was funny as shit to me. Hopping along, slap, 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 hop, 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 slap, slap, slap. Anywho, back out here in reality, what we're looking at is the mrf454. And my friend Tony, aka Charger over at ICA, he sent this over here for me to play with, break, abuse, whatever you want to call it. And maybe we've had one or two of these come across our way already, but I wanted to make sure I had the same lot numbers. It was in this box so we can have a one-to-one comparison. Anywho, the box is totally functional. We haven't really even started looking at this yet, but this here I wanted to show you the inside of the wafer on the chipset. Are you going to focus on the right spot on the screen? Hello? Camerito? Camera? Hold on, guys. We're going to go to Al Manual Labor here.
Manuel.
I know that was so hard to figure out, wasn't it, camera? I know. You got your big education in Japan, eh? You're having to slum it with me in Idaho, I know. Let's sweat the top off this thing. I will give this to HG. Their print's getting better.
I kind of like the one that was lasered on. Oh, look at that.
Isn't that pretty? Now what that looks like to me is like a 2879C, but minus a wafer pack. Let's turn our exposure down so everybody else can enjoy the brilliance of the video here. See what I'm saying? 7 and the 4 chipsets with the high cell count per freaking transistor wafer, because it's technically wafer number 1. And then this one here is wafer number 2, and that one there is wafer number 3. But instead of the chipset being rotated this direction like on the 16D08, they've started changing that orientation.
I've got the deal with a bunch of them.
These things run really good. I was really quite pleased when I hooked this 4-pill up. I was really quite pleased on how well it runs. Which, guess what? We're now going to demonstrate.
Yeah.
So we already know how this is going to turn out. You and me. We know. We've got to bring everybody out there in YouTuber land up to speed on what's going to take place here. So we're going to use the Bench 2950. And as we can all clearly see, we're at about 12 volts right there. So in a realistic world, this is realistic, like a 20 watt radio going straight into this 4-pill. No driver, nothing. You got the variable all the way open. So let's do this first. That is a 1,000 watt slug in peak, 1,000 in average, and a 5 watt slug in reverse. Back from the Bird 10,000 watt dummy load. We're at 12 volts. Okay. Let's get everything up here in frame. I'm telling you, this is an answer to a problem. These transistors are an answer to a problem, in my opinion. This is my opinion. So, hello, audio. Hello, audio. Okay. So putting about 15 watts. That's a mosquito catcher. We don't kill them big guys. They don't bite you, nothing. They just kill mosquitoes. I freaking love them. We're going to put about 15 watts in this thing and let's see what it does. Hello, audio. Hello, audio. Okay. Now, everybody out there in radio land's going, well, that's not too impressive.
It's at 12 volts.
Hello. Okay. It's making 390 watts worth of power. It's at 12 volts. So now we're at about 14.5. That's what the little digital meter says, right? 14.5?
14.5.
Hello, audio. Hello, audio. Isn't that pretty? Look, 500 watts, right? Hello, audio. Hello, audio. Hello, audio. 1 2 1 2 1 2 1 2. I'm getting a nice, smooth 520 watts worth of power out of this 4-pill. Hello, hello, hello. Let's go up here and let's take a look at the input tune. Hello, hello, hello. Hello, with 20 watts of drive. So now, the point is, if we max this thing out completely, we get about 600 watts out of a 4-pill. So now what happens if we build like an 8-pill? How much drive can we put in it? 100 watts. That's an 11 to 1200 watt amplifier out of an 8-pill. The perfect amount of drive from your like 2950. Perfect. So let's go ahead and let's fire up the old FLIR here. Wait for the old girl to boot. Das Boote. A booty tooty, Rudy Duty. The fun bit about this is that nothing really in here is hot. We go look at the transistor. It's 84 degrees. Let's back this out for everybody else to see what the hell we're doing. The transistor is at 84 degrees. But now what do we see going on with the transformers here, Zane? Look at how hot they are in comparison.
Quite a bit.
86. Now what happens, what makes the transformers hot? Saturation.
Saturation.
Pills are ice cold, dude, in comparison. Pills are 74. Transformers 91.1 or 98 or 91.9. So, what does saturation teach us? If the core of the transformer is getting oversaturated, that means it can't do what? Flux the power to the wire. So let me just slide in here real quick in post-production. I want to make this really clear. In my conversations with Charger, he explained to me that this is a new cabinet design for them, and his goal was to make it as small as possible using the smallest transformers without overly compromising any kind of performance. And I don't want you guys to get the impression, because of this previous segment that you just watched, that it was poorly designed. It is not. Contrary to that, it is the best compromises all the way around. Footprint, transformer size, inductor, capacitance, transistor, and efficiency. Okay? Keep that in mind. There's nothing wrong whatsoever with the transformers. It's just they are right on the verge of being overly saturated. He's a brilliant guy, y'all. Brilliant. And he knew this, and he told me that in all fairness. 1000% disclosure. He goes, look, I'd rather used a little bit bigger transformer to be on the safe side, but I think I'm right on the borderline. And he nailed it. Spot on. So don't get no confusion. Nobody go crying. Just straight up was designed for a specific purpose. For their new cabinet, for this part, for this design, for this operation. And it's right, not going over the line, but right at it. Which is brilliant. Don't get your stories twisted. Okay? Just saying. Just saying. Just saying. All right. Back to the other gobbledygook. That is a good running little box. I mean, it really is. That is a good design. Good design.
This case
is also custom.
Yeah, but this case I've always thought was just a little bit too small for like 42879s.
Agreed. Agreed.
Perfect for this.
Dude, do you ever see the miniature 4-pill cabinet they had before this, where it was about this much shorter?
No, I don't remember that one.
Oh yeah, yeah, oh yeah. No, this amount of heat sink with the amount of heat that's being generated by these transistors, perfect.
Perfect. Let's look at this. Right now it's producing...
That's the only thing it needs for a fan. It doesn't need a high flow, force your asshole, flapping butt wind fan. It doesn't. It just needs a little waft of air, because the pills are producing...
This thing's already doing what a Texas Star 500 does, and in roughly the same size package, but I think a more durable part, frankly.
Well, Texas 500, yeah, but this is only getting 20 watts of drive. 500, you got to put like 35, almost 40 in it.
Well, there you go. Winner again.
And this is at Class C, so imagine what happens when we put bias on it.
Really get up and move.
It'll pick up probably another 50, 60 watts. So I bet you we can get around 600 watts plus out of this. Easy. With bias. So let's reach over here and let's see what the Telltale machine says. Okay. Let's look behind the curtain. That's radio. That's amplifier. It's not too bad. That's not too dirty. That's not anything. That is really not that bad. And there's a little bit of grit on it, as we can all see right about, let's see here if I can get my finger on it, right about there. But that's 40, how many dBm is that down? It's 40 dBm down from principal. That's, I'm not excited about that by any shape, mean, stretch, or form of the word. I don't know. I played with this the other day, my man, I gotta tell you. And the beautiful people over there at ICA sent me my own transistors here today. The only difference is these are 20W45s, which which I don't know what that means because nobody knows what any of these codes mean. And if they do, they ain't telling me because they'll be afraid I'll put it on YouTube. Then we'll all know what the secret sauce squirrel magic's all about. They sent me MRF 20D08.
Who knows?
I say...
I don't know what lot I've got, but I've been happy with them.
I say... maybe I do a little bit of experimentation with these in my own cabinet, and let's see what we can get out of it in Class C and Class B. Because he sent this up for me to just play with, modify, tweak, have fun with it, and then he wants me to take it over the break and give it away as a raffle prize. So that means somebody, and I'm not touching this box from this point forward. I appreciate this because it got me motivated. Now, as he knows, after me getting to play with this, I've sold him not one but 2 8-pills based off of just this one box to run a 20, like 955. And 955 hitting an 8-pill or these 1200 watts all day long, sideband biased, dream. But I don't know, me personally, I think we can get more out of these than what we get out of the 2290 Toshiba.
I can tell you from personal experience, I've been getting more. I put them in Cobra 200s and
What's the results when you put them in the Cobra 200?
I got 20 more watts, same exact tuning. You put them in a Cobra 200. You want to put a metal clad 100 puff mica where the silver mica is in the output tune circuit, but 20 instant watts, and they don't run nearly as hot.
Yeah, they run really cold, is what I'm seeing. And I mean, short of the transformers oversaturating, which is something that we're going to definitely be able to take care of. I don't know. I'm really impressed with how cold they run. I don't know what special shmoo magic they've got on the inside of those tins, but there's something to it. So what do you think? Should I grab one of these? Here, we'll just grab this one.
Let's do it. I'm curious.
Go big or go home, right? Let's play. FatBoy, donated by FatBoy. These are the brand new 454 transistors. 30 watts, 600 watts out.
454.
600 peak out. Assume that's a donate. FatBoy directly. It's a 454 4-pill. Yep. It's got 454 transistors in it. 4-pill.
Oh, I can tell you who this belongs to. This belongs to that cricket.
HG.
Bondo.
I only put one.
Oh, yeah. I know. I'm glad that's why I said the cricket.
Good job.
Well, my product demonstrator is basically done. I don't know what my input capacitance is going to be, and I don't know what my output capacitance is going to be, so that hasn't been added yet. Got our standard bias set up. I got to measure that too. I got to measure the current load on the input transformers yet. Good morning, by the way. So we've made a little bit of progress. Transistors are down. And I want to leave everything above board, all the wires, everything in the cabinet above, and very basic bias circuit, nothing too overly flamboyant here. We went with the bigger transformers. I think that if they were to change, add like another, not even a ½ inch, maybe like a 1/4 inch bead to the transformers they're using over there, they probably wouldn't get the heating saturation issues going on. But I mean, that amp that I was sent up here to test is, God, it runs really, really cool. It runs really, really cool. So my goal here is to teach myself more about the transistor. We've diverged from his capacitance mix on his input and output transformers to what I have taken a slightly educated guess, and I mean very slightly educated guess, on what we need for a capacitance mix. So what I'm talking about is the input and output capacitance mix. So what we'll do is we'll get this thing running, and the first thing I'm going to do is I'm going to get the bias set so I can watch that, which is a little bit of a trick. But I want to bring that on board first. Of course, we'll establish a very basic input and output tune, and then we'll go find our maximum amount of peak power. After measuring the input impedance, because the data sheet we get from China is just bullshit. It's basically, let's go download Motorola, and then we're going to delete Motorola off the data sheet, and then we're just going to put HG. That doesn't mean anything. It's not helpful information. And once you get into get into it, you'll understand that your input impedance is king. That is what determines all of this. Input and output impedance of the component determines everything. So, yeah. So I went ahead and I ran this thing through on the machine, and I know the number that we're at. And yeah. Whew. I need to have a cup of coffee this morning. I'm dragging. But the next step is to set this aside for right now. And let's populate the cabinete. Well, let me just step out here real quick first and say, listen, this is the end of an experiment and the antithesis of perfection. This whole video has been shot over a series of about 4 weeks, almost a month at this point. And I've had to interleave this in between other projects and other adulting responsibilities I've had. First things, let me just big shout out to ICA for one, sending that box over for the break, and two, the question was posed, and you guys don't know the question, and I'm going to show you the question here in a minute. Thanks to him for sending that over for the break and inspiring me to start messing with this, because I am the last one to the show when it comes to this transistor. I don't get a lot of time. I don't get a lot of time where I get to go and experiment anymore. There's so much pressure on me to repair, or what about this and what about that, what about this, what about this, what about that. I have been a little out to left field. I'm not gonna lie. I'm not gonna sit here and try and make excuses. I've had other things on my plate, and him going, dude, I want you to take this transistor amp that I built. I want you to play with it, look at it, think about it, and get back to me with notes. And not that he needs my help in any way, not that he requires my input or thought on anything, because he does not. But for one builder to another, honestly, to simply say, here, look at this thing, evaluate it, come back at me with some notes, it's refreshing. It's like a breath of fresh air. It's like, hey, we're adulting. Okay. A lot of the other guys are going to run around and say, oh, I figured this out, blah, 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 ooh, oh, that's not what's going on here. I think what he was really trying to do is inspire me to come look at this component and just simply ask me one question. And I appreciate that kick in the ass. I really do. I have been stagnated in the research department now for months, because it seems like every time I turn around, I got to go out of town. As you guys know, just before I shot the very first segment of this video, I'd just gotten back from Texas, where I had literally had to go take my best friend, or one of my best friends, to the hospital and say, hey bro, get better. And it has led to me to where we're at now, almost a month later, and I got to turn around and go back. In this box, I've just been working on it in between. Me and my buddy Zane started in on this thing, but the whole idea, because we have such a long lead time on getting cabinets and parts and transformers and wire, and the idea was put forth over a month ago, and we're here today. Unfortunately, in this amount of time, there's been a lot of upheaval in my little universe. I ended up losing Mr. Black. Mr. Black Productions was a real guy. That was a real entity. And he's gone on now. He's not with us, and I've got to turn around and I got to go to Texas in the next couple days I want to go be with his whole family. And I came home. I should have stayed in Texas is what I should have done. But I came home to go get ready for the BBI Bakerman break and get all that ready and paid for. And all that business taken care of. So we could have a celebration of radio in the Northwest. I came home from the break and I did not want to touch anything radio related. Hell, I didn't even want to answer my phone, but the show must go on. So I returned phone calls. I needed some time. I mean, literally, I'd had people here almost every single day from when I got home from Texas until I left to go on the break. And in the middle of that, I lost one of my closest friends and a business partner. And I had not taken any time to process any of that. And I was getting really shut down inside. I mean, on the way home, my wife's like, babe, you've got to stop for a minute. And you've got to take a minute to process this loss. You have to work on you. And I'm like, babe, I don't want to work on this stuff anymore. Because I was so burnt out and so frustrated. But she literally pinned me to the floor and says, no, you're going to have to take some time. And I'm glad she did that because I'm here and I'm completely revigorated. I got so much fun stuff over here to work on. I can't quit and I ain't going nowhere. We're just going to keep getting better and growing and being stronger as a group of radio operators, and hell, need I even say a little tiny business. So everybody that came and participated at the break, I want to say thank you to every single one of you guys. I'm glad that we had the opportunity to be able to get together this year. I really am. Taking into account everything that's going on. I can't say anything more about everything that's going on because YouTube will suppress us. So, on that note, let's move on. The question has been raised, and it all revolves around radios like this. Yes, the infamous Striker 955. The question is, and it was put to me by Charger, and I'm sure he's posed this to many other builders, and I am in no way special, unique, God's special little flower in any way. I am just a cog in the machine, a button on the droopy, dribbled on fly of the universe of pants, okay? The question has been put forth, what is the best amp that we can put behind a 100-watt radio? Well, until I've had the opportunity to mess around with these transistors, I would have argued staunchly that you want to use a 4-pill 2879 box. That was the argument. That was the question. That was the consensus of thought was, yes, if you have a 955, you want to hit it into a 4-pill. I now staunchly disagree with that. I argue the opposite direction now. I have seen some tremendous characteristics with these components. I'm going to show you this thing operate, and the efficiency rate of these transistors is off the charts. It's off the charts. So, well, it's not off the charts. It's just really good. Seriously, it's really good. Do we want to take a 100-watt radio and drive it into this thing? Nope, we do not. We do not. This particular amplifier is set up for 35 watts of drive. Very, very, very low drive. 35 watts PEP. So you take your standard Cobra 29. You take your standard, 2950 that hasn't been hopped up and modded up to make 1 billion watts. You take your old school radio that does about 35 peak watts and you put it into this, it's going to make 600 to 700 watts of power. You said, what BBI? You heard me, 600 to 700 watts of power. Okay. Why is that important? Well, if we take a 955 and we run it into a standard 4-pill, what we get on over here in the old watt meter is we get about 800 watts of power. Boop. With 100 watts worth of input power. Okay. Sounds great, right? Whoop. With BBI, we're talking about this 4-pill. Right. This is my product demonstrator per se, but because I had the guide of charger sending me that out of the box and said, here, take this design, run with it, tweak it, give me notes. I went ahead and I did exactly that. And so the format that he worked within was a 4-pill transistor amplifier. So I have to do the same thing. Now, this being said, I've had several people call me with this same question. I have a 955, what should I put behind it? And I in turn have turned them around, U-turn, get off the next exit, let's go back the other direction, and send them directly over to charger. The reason I send them to charger is because I don't have enough flexibility or time or the ability to turn things out of here quick enough like he does. A lot more people working for him than I do. And said, hey, you know that project that me and Charger have been working on, that idea? Let's go test drive it because I think it's doable. I think it's 100% safely doable. So what I said is, guys, when you call over, you're going to want an 8-pill with sideband bias, with bias, and it is necessary to have bias. If you're going to use the amplifier on sideband, you have to have bias, especially with a 955, which is a primarily biased radio, even though a lot of guys use it on AM. Listen, he's already built a couple 8-pills in this configuration. That's how much time's gone by, okay, since I was able to start on this thing. I'm just wrapping this up so you guys can have some, conclusion to this video. And it works perfectly. And the results directly correlate to the environment that's around the amplifier. So let's say, like in this situation where we run at 15 volts, because I know the voltage is going to sag, so we're actually running internally at 14.5, 14.8. But over here at the test points, over here, we're putting 15 volts at it. Well, let's say a guy puts 15.5 on it. Guess what? He's going to get 700 watts for every 4 transistors. So you put a 100-watt radio into an 8-pill version of this, you're going to get 14 to 1500 watts worth of power at almost a 70% to 75% efficiency ratio. I don't know what North did when he made these transistors, but he sprinkled a little bit of dust on them and they took off like a raped animal. The Texas Star 250s, all that kind of stuff, I'm now going to say instead of using a 2290, they're getting this transistor. This transistor impressed me that much. It just did. So you can take a 4-pill that is going to get relatively, and that's the other thing. These transistors produce like half the heat. I know this looks like just a carbon copy of what I normally do. This capacitor is different. These are different. This is different. That is different. Each one of these diodes are different. The turns ratios stay roughly the same, but how we tune the amp is completely different. Completely different than an HG 2879C, 2879, 2290, 1446, any of those other things. The capacitances are completely unique and special to themselves for this particular build. I think this is the answer to the question, what do I put behind my Striker 955? It's easy, 8-pill. 455, last you forever. It runs. I mean, like, the fan that he had on his amp was maybe a 3-inch little fan, and it was barely turning because these don't produce the heat. The 2879 produces an ass ton of heat for what it's making for power. Hence, the more efficient. Okay, let's go over here and let's take a look at some stuff. Let's make sure I got this scale set up properly. We're on 1X. This is a 100-watt slug and forward. This is 1,000 in average. Of course, the 5-watt dummy or 5-watt slug and reverse back from the Bird 10,000-watt dummy load. Our volt and amp meter up here. And up here we've got a 5 watt element in reverse between the 2950 and this beautiful beast. Okay, so let's go over here and let's show you drive. We're on the 100 watt scale right now. Moreover, let me do this. Let's start here. Let's take this 5 watt element, we're going to put it going forward. So now we're reading the power going through the meter sections. We're going to put 1 watt worth of power, 9.9 tenths worth of a watt worth of power through the meter. Now, that 1 watt translates to that much movement on that meter. Everybody got that? Good. Okay. So 1 watt worth of power in translates to about 12, 13 watts of output power. Okay. Hello. Hello. Just a hair over 35 watts. On 15 volts. Okay. Turn the amp back on. In the corner. Now we're going to take it up to 2 times. So 2 times. Now full meter deflection or full needle movement is 200 watts. Let's go down to 5x. So now we're looking at the middle set of numbers, the 10, the 20, the 30, the 40, the 50, and we're adding a 0. We're getting close. We're getting close to a unit of measure that we all understand. We're not quite running the meter completely freaking flat out, ding, to the stop peg. This is now a 1,000 watt slug, or 1,000 watt element, going forward. Hello, audio. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2. That's with the plain Jane 35 to 40 watt radio, hitting it on internal voltage inside the box at 14.8 volts. I mean, the amount of heat that's produced is the thing that really has got me excited. I mean, honestly. So let's go over here. This is our pass through the amp. Okay. Here's our input tune going into the amplifier. Hello 1 1 1 1 1 1. Hello 1 1 1 1 1. Hello 1 1 1 0. Pretty good. I'm happy with it. I think this transistor is an answer to a lot of questions. The 2290 HG transistor that is a copy, supposedly, of the Toshiba does not work like this. It doesn't, I wish I had the vocabulary to explain to you that it's like it's struggling to do the power, if that makes any sense. The 2290 HG, because look, the real deal Toshiba 2290s are getting really expensive. They're getting silly expensive. They're doing the same thing that Toshiba was doing. You know, $130 a part, where this is like $20 a part or $22 a part or whatever it is. Hello. What I'm getting at is the 2290 copy of this. It loads basically the same. It has the same amount of capacitance and stuff around it that the regular 2290's got, but it doesn't work this well. This works better than the HG 2290 copy. That's what I'm getting at. This is a superior component by all means. All means. So for those guys that are interested in calculating efficiency here, Hello. 54 amps, 600 watts of power. So how we get that is you take your voltage times your amps, and then you have to reverse calculate that back for the efficiency of the component for your power displayed. Okay, and you'll find there's about 130 watt difference, 140 watt difference between what we have going on here versus what that says we're supposed to be making. So you take volts times amps, gives us watts, and that's total amount of energy consumed by the amplifier, then divided by the efficiency. And you take that percentage. I usually like to start at 0.60 because most bipolars are in the 60 to 65% range. And you'll find that if you do your math, you're going to be somewhere between 28 or 68 and about 74% efficient. This giant piece of heat sink is only having to dissipate a couple hundred watts worth of heat. Okay? Think about that for a minute too. What's going to last longer? The more efficient component that requires less drive to make almost the same amount of power and has more heat sink underneath it. I stand here saying I think this transistor might be the answer to a problem. Is it really a problem? No. But is it the best thing that we've come up with to be able to put behind a 100 watt radio, or 120 watts to be able to push it? You give me an 80 or 90 watt radio and we can give you a 12, 13, 1400 watt box. It's all in one unit, doesn't require any kind of drive. So it's basically like a Texas Star 1200. Think about it. The light will come on. I guarantee it. This has been a fun adventure. And once again, I cannot stress this enough humbly. And I don't want to hear any grumblings about how somebody decided to call church. Oh my God, BBI, the YouTube video, he created the sun and the moon. That is exactly not as what happening. Okay? You're going to look like a dill hole if you decide to do that. Because I am saying humbly, gratefully, hey man, thanks for letting me be involved in the party. And I appreciate you bringing this to my attention. And I also appreciate you motivating me to play and do something fun for a change. So this is Master Builder class number 18. This is specifically set up for sideband, you guys. There's no effing around here. Somebody's going to go put this in their car, and they're going to talk a ton of schmack with this thing on sideband with all their buddies. I don't have a giant high flow fan in it that makes a ton of noise. You can sit right next to this thing and it's whisper quiet. Why? Because we're not dissipating that much heat. We have a large heat sink source to absorb all the electrical energy that is being produced in the form of heat. Little tiny sun on fan. Done. All right, my rant is over. Look, this is how this goes. I want, let's say $700 for this. I'll throw in the ride. The first one to call me, I'm only taking PayPal only on this deal, period. So there we go. You guys all know the drill. The first one to reach out would be the call or text, gets the answer, and I will tell you, yes, you're the first one, or no caller. You are caller number 15, 19, 20, and 35. Seriously. I don't care where this goes. I've written down all my notes. I don't need to put it on the shelf. It is a absolute beautiful creation on the inside. Now guys, I want to say thanks for bearing with me. I am going to take off. I got to run to the other side of the United States. I'm going to go work with the family and trying to get rid of some of the equipment, disassemble the station, make that little portion of the universe a little bit more copacetic for them, and turn them, bringing it all the way back here, and we're going to get rid of all of it. It's going to be passed on back to you guys to help the family out in whatever way that they deem necessary to do whatever they want. It's not up to open to me. I don't care. It's going to get a little thin for the YouTube videos here for about the next week and a half. But believe me, when I come home, we're going to make up for it on the other end. Seriously. Charger, thank you. You didn't know it, But through you, I had a little bit of life flowed back into me with building this thing, and I want to thank you for the motivation. Gentlemen, I got to run. Where this ends up, I don't know. Who gets it next? I don't know. I love this game. I love it. I got to run. You guys be good. I'll talk to you here in about a week or two. We'll see you. Click, click, click.